Hello everyone, this video is about 4-bar mechanism. You will learn how to animate linkages using Python script in A2plus Workbench. Please watch linkages movements. If you are not familiar with kinematics, request to watch some videos to understand the concepts of kinematic chain and degrees of freedom. In this channel, you will find many mechanisms for practice. You can take links dimensions from available videos. Also, this video will be helpful to you, in which you will learn how to link sketch dimensions with FreeCAD Spreadsheet Workbench. This spreadsheet will give you basic idea about 4-bar mechanism. Let's define crank and rocker link. Crank can rotate a full 360 degrees. Rocker can rotate through a limited range of angles which does not include 0 degrees or 180 degrees. 4-bar chain has 4 linkages. Input link, which is connected with input drive or power supply. We have set alias IL for this. Second link is output link. We have set alias OL. Third link is ground or fixed link. Alias is set to GL. Fourth link is coupler link. Alias is set to CL. There are 3 conditions, T1, T2, and T3, on which the movement of a quadrilateral linkage can be classified. For more details, you can visit Wikipedia. Case 1. 150 mm for input link. 120 mm for output link. 100 for ground link. 150 for coupler link. From these values, T1 is a negative, T2 is negative, and T3 is positive. An input link will be crank and output link will be also crank. Let's enter values here to get sign for T1, T2, and T3. T1 is negative. T2 is negative. T3 is positive. Now we will make these 4 linkages. Select Part Design Workbench. Create a new body. Create a new sketch. Select XY plane. Click OK. Turn on grid view. Click here to create a link. Add 2 circles at arc centers. Provide radius. Define link length. You can see 2 degrees of freedom are required to make this sketch fully constrained. Select coincident constraint and constrain sketch. You can see fully constrained sketch. Close this sketch. Select Pad tool to extrude this sketch. Link is generated. Let's link length with Spreadsheet. We will make this link as an input link. Rename link name. Double clicks on sketch. Select length constraint. Click on expression icon. Write input link alias. Click OK. Turn on auto update. Close this sketch. Copy input link data by right-click. Turn off this. Select Body, Sketch, and Pad. And click OK. Paste here. Change link name. Edit sketch. Click on length constraint. Change alias for output link. Click OK. Close this sketch. Hide this. You can see output link based on spreadsheet dimension. Let's create ground link. Press Ctrl C. Select body name, pad and sketch. Click OK. Paste here. Change name. Make a link with ground link dimension provided in Spreadsheet. Click OK. Close this sketch. You can see ground link. In last, let's create coupler link. Press Ctrl C. Select body, sketch, and pad. Paste here. Change name. Link coupler length with Spreadsheet alias. Click OK. Close sketch. You can see coupler link. Let's make sure that each linkage length is properly linked with Spreadsheet. Change value for input link. Model is updated. Check for output link. Model is properly linked. Check for ground link. Model is updated. Check for coupler link. Geometry is updated. Save this document. Select A2plus Workbench. Follow the steps to download A2plus Workbench. Click here. Read Introduction about A2plus Workbench. Install. Select A2plus Workbench. You can see Workbench is installed successfully. Back to our problem. Click here to add new document. Document is added. Save this document. Click here to add shapes from external file. Select ground link. Add shapes of input link. Click to fix link position in workspace. Let's change link color. Let's define circular edge constraint between two whole edges. Click here to add constraint. Select input link. In properties, change angle. You can see link rotation. Open Python console window. Again change angle and observe Python console window. We will use this link property from Python console to move this input link. We have made a script to animate this. Activate required modules. This line will set the duration of each step. This line will set the angle increment per step for the input link. This line will set the number of alternating movements, in terms of clockwise and anti-clockwise. This line will set the desired maximum angular movement for the input link. This line will calculate the total number of steps per movement. This line will calculate the time delay per step. Below for loops will be used to animate the alternating movements. Up to defined movements. Please replace this line from the Python console. Copy this line. Paste here in first movement. Also paste here for reversed movement. Here only variable is rotation _ angle. Copy this variable name and replace here. Same for the reverse movement. This script is now ready to use. Copy this script and paste in Python console. See the animation. Adjust view. Paste script again. Change angle movement. Copy modified script. Paste script here. In case of continuous movement, follow steps. Change minus sign to plus sign here. It will double the movement. Expression note. Copy this modified script. Paste here for continuous rotation. Now we will use same methodology for 4-bar linkages. Import ground link. Change its color. Import input link. Select circular edges. Define circular edges constraint. Accept. Check for rotation. Change link color. Add coupler link. Select circular edges and define constraint. You can modify properties and click on Accept button. Import output link. Select circular edges and define constraint for both ends. You can select axis coincident constraint also. Change link color. Change angle. Click on Solve Constraints tool. We will add Solve Constraints command in Python script. Copy this line. Paste here in first movement and second movement. Copy this script. Paste here to animate the 4-bar chain mechanism. You can change background color. Change for continuous rotation. Change number of rotations. Copy and paste script in Python console. Now we will see case 2. Change values for input, output, ground, and coupler link. Save this file. Update parts in A2plus Workbench. Copy script and paste in Python console. Focus on input and output link rotation. Input link is crank and output link is rocker. You can use the same script with minor changes for remaining 2 cases. See you in next video. Thank you so much for your support.